Hello students, today we will consider yet another concept in the topic of basic concepts of chemistry or mole concept. So let's begin. Today we will study about mole fraction and how to proceed for numericals using this concept of mole fraction. So what exactly is mole fraction? So when you have any particular solution, you have two components. One is solute and another is solvent. So over here, let me consider A as your solute and B as your solvent. So the number of moles of A is denoted as Na, and number of moles of B is denoted as Nb. That is the moles of solvent. So mole fraction of solute, if you want to find out, then it will be equal to Na upon Na plus Nb. That is number of moles of solute plus number of moles of solvent. However, if you want to find out the mole fraction of solvent, it will be Nb as the numerator and Na plus Nb. However, in both the cases, mole fraction of solute and mole fraction of solvent, they will together combine to give you in total. Addition of both of them will be equal to 1. This is valid for a single solute and multiple solutes. So let us consider a numerical pertaining to this concept. We will correlate over here the mole fraction and molality of the solution. So we have calculate the molality of aqueous solution of any unknown solute if the mole fraction of water in that particular solution is given as 0.60. This is the data which has been given. So let us see what data has been given and how do we go about it. So I have been given not number of moles of water. I have been given the mole fraction. So just now we have seen the formula. I am considering over here the moles of water as N1, number of moles of solvent, that is water, as N1, and number of moles of, I'm not writing it again, number of moles of solute as N2. Okay, so the data that is given to me is N1 upon N1 plus N2 will be equal to 0.6. So if I want to find out the mole fraction of solute, so we know the formula very well, N2, that is moles of solute upon N1 plus N2, number of moles of solvent plus solute will be equal to 1 minus 0.6 because mole fraction of solute and mole fraction of solvent is both equal to 1. So I'll be getting 0.4, that is nothing but your mole fraction of solute. Now how do we proceed from here? We have now two quantities. One is mole fraction of solvent, that is water, and one is mole fraction of solute. So what I do is I divide N2, that is mole fraction of solute, with mole fraction of solvent and get a ratio that is equal to 2 by 3. Now, in this equation only, we are very well aware about the molecular mass of water, which is nothing but 18. 2H2 means 2 and oxygen is 16. So 2 plus 16 will be equal to 18. That is molecular mass of water. Plus we have to calculate in totality molality. So that will comprise of 1000. the solvent will be 1000, because generally in molality, the mass is calculated of the solvent is taken in kgs. So I can easily substitute over here, because moles is what? Moles is nothing but the weight of your whatever, in this case solvent, upon molecular mass of solvent. So I know this formula of moles. I'll substitute over here. N2 is something which is unknown. 1000 is water content and 18 is the molecular mass. And plus I have the ratio. So I can easily calculate the value of N2. That is number of moles of solute, which is unknown. So this much moles, 37 on mathematical simplification, 37.03 moles is the number of moles of solute. And hence molality, in terms of molality, because I have already taken it in the solvent in 1000. So molality of the solution will be what? 37.03, because